right, we'll go ahead and get started with our main presentation. Jeremy, you want to come on up?
Sure.
All right.
Just gotta set my laptop up real quick. How's everybody doing tonight?
Awesome.
All right. I should hope so. Oh, it's on. Hang on a second. I actually never use this thing on with two screens, so I just have to switch the monitors over. I've seen that the Brett Victor talk before, and it's really inspiring. It actually inspired some of the stuff that I'm going to go over tonight. How do I switch the monitors here? Displays. How do you clone a monitor on a Mac? Oh, here we go.
Yeah. Mirror. Yeah.
Hey, your business. Alrighty, now let me just sit there. Perfect. So, hi everybody. Thanks for coming out tonight. I'd like to thank Groupon for hosting this awesome meetup and everybody for showing up and seeing what I have to say today. My name is Jeremy, and today we're going to talk about three things. We're going to talk about the basics of animation on the web. We're going to talk about some interesting patterns for making animations easier. And we're going to talk about some tools that I'm working on to make life easier for building these fundamentals and these patterns. So the title of this talk is called Web Animation Done Right. So if there's web animation done right, then what's web animation done wrong? You could also ask yourself, is there web application is done wrong and done right? So what's the difference between software done right and wrong? It comes down to a lot of things, but I tend to think about the tools and the patterns and the approaches that we take and the way that they scale. Turns out that that's true for animation as well. So let's get into it. So first off, hello again. Who am I and why are you listening to me? My name is Jeremy Kahn. I'm a web developer at YouTube, and I love writing open source JavaScript libraries. We're going to go over some of those today, and if you'd like to follow along, it's all on my GitHub at github.com/JeremyCKahn. So let's break down the basics first. So how do we animate things on the web? Not counting jQuery or any other fancy tools. We're either going to use JavaScript or we're going to use CSS. Now, these each have different use cases and very different implications depending on what you're trying to do. Let's explore JavaScript first. So if you're making an animation with JavaScript, just pure JavaScript, you're either going to set timeout or request animation frame. These two methods are very similar. All they really do is schedule a function to be called at some point in the future. The only difference between these two is that set timeout allows you to request when you would like that to be called back, whereas request animation frame takes care of it for you. So here's a snippet of code that uses set timeout to do a basic animation. It's a little dirty, but it's good enough for demonstration purposes. So we're going to grab my elf in the DOM, we're going to set up some basic stuff, and we're going to start this update loop. This update loop just updates the style on the DOM, and then iterates the left by 1, and then schedules another update. You can see that with set timeout update 1000/60, which means this will try to call itself 60 times every second. So here's a similar snippet. In fact, only one line is different, and it uses request animation frame. Again, it's just giving itself a reference to its own update function, and it's going to try and call itself 60 times every second. Now, request animation frame is really cool, but there's a few things you have to know about it. It's not available everywhere. I think it's only available in WebKit so far, but there are shims to allow us to use it in more browsers. And what it tries to do is it tries to schedule a callback at a time where the browser is most likely to render it efficiently. So it's a bit of a micro-optimization, but it can make a huge difference depending on your animation. The chances are you don't want to write all this boilerplate code. You're probably going to use a library of some kind. Probably jQuery. This makes things really easy. This is much better than the big chunk of code that we had before. And it's also much more scalable and, for the most part, faster. So why would you want to use JavaScript to animate something on the web rather than CSS? There's a few reasons, but most importantly is that it's flexible. You can run a JavaScript-based animation anywhere that you've got JavaScript, any environment. You can run an IE6, you can generate animation output in Node. It works everywhere, so it's great. But the problem with JavaScript is that you're not going to get the best performance possible with it. JavaScript engines have gotten faster, but they can only ever do one thing at a time. So if you have a lot of things animating, everything's actually happening sequentially. You can't multitask with JavaScript. So now I want to talk about CSS animations. Again, there's two APIs. There's transitions and there's keyframes. I think they're similar, but they're a little bit different. They try to accomplish different goals. Let's talk about transitions first. Normally when you apply a style to a DOM element, the style is reflected immediately. So if you change the color or one of the dimensions, it happens instantaneously. What a transition allows you to do is allows you to animate to that new state. So if I have a transition on something, specifying that it's going to transition to the left property, and I change that left property with JavaScript or a hover state or something, it will actually naturally ease to that new state. And this is great in most cases, because things in nature don't really happen instantaneously. Keyframes are a little bit different, and I'll get into that in a moment. But first, here's an example of using a transition with CSS. This is just taken from the Mozilla Developer Network, and all it's really doing is applying a hover class on element delay 1. When you hover on delay 1, it'll wait 2 seconds, and then it'll just grow the text. If all you need is a basic transition like this, and you don't need jQuery or any JavaScript on your page, this is a much better way to do things. It's much less code, much less to go over the wire to load onto the client. This is an example of keyframes. So keyframes are different from CSS transitions. Keyframes allow you to specify any number of points between the beginning and the ending of the animation. So you can change the rate of speed very granularly, or you can even move things in a completely different pattern so it's totally non-linear. It's really pretty cool. For example, this one just takes, it's an animation called slide in. It just animates the margin left from 100% to 0%. Now what's not shown here is all the indeterminate amount of middle points here. You can have 0 or you could have hundreds. It really depends on what you need. So that's pretty cool, but what are the pros and cons and caveats of using CSS to animate the web? The biggest reason to use CSS is that it's faster. It's better performance. CSS can access the GPU. This is something that JavaScript cannot do, at least not yet. Your computer's graphics card is getting much faster at rendering to the screen than the CPU ever will be. So we want to take advantage of that power. But you can't always use CSS. For one, it's not available in older browsers. So you can't have a CSS animation run in IE less than 9. Also, if you want to have a lot of control over your animation, you don't have that many easing formulas of CSS. I believe there's only 5 or possibly 6 that are built into the browser. So now I want to discuss a little bit of theory. Who here's heard of keyframes before? Okay, looks like about a quarter of you. I'm guessing there's some X-Flash people in the room, or yeah. Okay, so there's some X-Flash people in the room. What are keyframes? Simply, keyframes are a way of defining different parts of an animation in time and space. So if we look at this ball example, you could think of this as a 4 keyframe animation. So this is the first keyframe. Let's say it's keyframe 0. This one lives at keyframe 2 seconds, and then 4 seconds, and then 6 seconds. When we play this animation, the ball is going to go to each of these points at the times that we specified, and it'll just interpolate these middle points based on real time. This is a really powerful way of creating an animation. It's powerful because it takes a totally different approach than the jQuery style. So who here is familiar with the jQuery animate function? Okay. So it's a powerful thing, and all that does is it makes a tween. It's a chainable tween with a callback. The keyframe approach is different though, because with the jQuery animate style that's got just a tween, you just set the animation to run. Basically, the animation, it's duration-based animation. So you can set it for 2 seconds and then wait for a callback, or possibly chain them sequentially. With keyframes, this is great for organizing a whole bunch of different actors on your screen because you can synchronize them very easily. You can have all of your actors, start or stop at a given keyframe. So if you all want them to go to meet at a certain point at 5 seconds in, keyframes are a great way to do this. Well, yes?
So like set timeout and I think request animation frame, like if you say I want a timeout 60 times a second, you may not get that?
Right.
Because of the speed. Are keyframes the same way, or?
CSS keyframes?
Yeah. I mean, is it dependent on how much is happening? Because that's how, like with JavaScript and set timeout, it depends on how much else is happening in the queue.
Well, you'll drop frames. That's actually good, and we're going to get into that in just a moment.
Oh, I'm sorry.
Sure. So those are some animation patterns. Now, what are some animation anti-patterns? There's patterns and anti-patterns in animation, just like there are in application construction. So here's the same snippet for request animation frame as before. Who can tell me some things that might be wrong with this snippet? There's a few things wrong, but I'm wondering if people can see just off the bat. Yeah?
You're running your physics in a frame-based way. So if you drop frames, you won't move left as quickly.
Right. Well, the problem is we're actually not going to drop frames. We want to drop frames because we're iterating the left by 1 here. So we're going to generate the current state based on the last one that was rendered. Now, if the previous state was late, or even if this one's late, then we're still going to get the same state that we wanted, but that state's going to be generated later. Now, this doesn't seem like a big deal, but these stack up. So if this ends up getting called 300 times over the course of a few seconds, and it doesn't run on time each time, the animation will run late. It'll run in slow motion. One of the key takeaways to take away from this talk is that it's better to drop frames than run in slow motion. Another key takeaway from this talk.
What do you mean by drop frames?
So, dropping frames is... I'm sorry? So you want to animate, you want to end at a certain point. And if you can only render 70% of those frames, you want to render those when they're supposed to be rendered. You don't want to just stack up. You don't want to make a queue that just waits in line.
I never get to that.
Right. Like, it's maybe not the greatest example, but if you're working in a fast food line and you want to close at 10 o'clock, you've got a really long line, you don't have enough time left before 10 o'clock to serve everybody, you may just pick out several people in the middle of the line so you can get out.
Great. As long as you don't drop off the table the frames that can point back to where you were before.
Right, and also, because if you don't, then you're not going to get home in time, and you're going to miss Lost. So.
Oh, hate that.
So we want to drop frames. We want to kick our customers out. Maybe. Oops. So that brings me to my next point. This is another key tip. Yes?
So have you thought about what you would do from a cost perspective?
From a what perspective?
Cost.
Cost.
Quality of service. Quality of
Doing
service.
phone conversations or
QoS.
that require that you don't want to be hearing words out of order or hearing words on top of one another?
That's a...
Package get there. So I was curious, from a cost perspective, if that exists within this framework, is that something we'll be talking about tonight?
Not really. It's kind of an apples and oranges thing, because an animation is very time-based, whereas a cost thing is you need to serve everybody no matter what. So I guess if you're getting paid really well to serve people in this fast food line, maybe you'd stay. But again, it's a bit of a different concept, so it doesn't really transfer over too well.
In a web context, it's a streaming context. So you're saying with keyframes by definition, because they're time-based, you're going to point to the other keyframe. And if you lose one, you may get a little flicker, but because they're all time-based in the structure of them, by definition, you're going to lose some or not. You're still going to just go past that. You're going to keep going.
Yeah, well, you want to hit each keyframe at the time you specified, not late.
Right, right. But I mean, by definition, if you lose some, you've got a way by looking at it, you're going to go to the next one.
Yeah, exactly. So another big takeaway for this talk is that state logic and drawing logic must not be tightly coupled. This is what allows us to drop frames properly. Let's see what I mean by that. So this is a better way to structure an animation. This is just pseudocode. I don't actually have any logic in here, it's just a way of organizing things. So instead of just one update function, we've got 3 now. We've got update, calculate state, and draw. The important thing is that calculate state calculates the state based on real time. This will drop our frames. This is what we want. I should mention that we don't want to drop frames. That's not good, but some performance trade-offs are necessary. And again, it's better to drop frames than run late. So all update does is it calls calculate state, passes that to draw, renders it to the screen, and then it schedules another update with request animation frame. Another way of thinking about this is called a controller, a model, and a view. Model view controller, MVC. Who here is familiar with the MVC pattern for software development? A lot of you. So I'm guessing there's some Backbone users in the room, or users of another similar framework. I love MVC. It's great for a lot of things, and it turns out that it applies to animations as well. So what is MVC in the context of an animation? So a model maintains a state. View renders the model visually, and the controller just controls the model. It's a little bit different from an architecture standpoint for an application, but it's pretty similar. But the interesting thing about the MVC pattern for an animation is that the model's consistent, the controller's consistent, but the view is not. We can guess how these should work for every animation that we're ever going to build. We want to animate based on time and then control the play, pause, or stop state of it. But the view is going to change. We may want to draw, a ball, or a turtle, or a square, whatever you need. So this is what we need to worry about. One way of thinking about this is to just ignore the controller for a moment and look at the model and the view. So the model in this case is just an object. It contains an x and y of 10. And the view is just our magic draw circle function. Again, the logic doesn't really matter. It's just for demonstration purposes. So we pass the model into the view renders it to the screen, and takes the ball and puts it in the upper left of the canvas. And we wait however long this animation is. Oh, whoops. There we go. We wait however long this animation is, and now the model is at x200 and y50. It's still the same it's still the same view function. And all it does is take the same circle and render it over here. So a little bit more theory. Does everybody know what easing formulas are? Okay, there's a general consensus of yes. For those who don't, or for people who need a refresher, when you're animating something, by default, it moves at a steady rate throughout the course of the tween. But this doesn't look very natural. You don't see many things in nature that move at a very linear rate. And you'll see on the web, especially the jQuery because it's built in, that things just kind of ease into where they're going. So they'll start really fast and then end really slow, or the opposite, or they'll do any number of effects, even a bounce effect. Like that's not going at okay, that's actually running at a linear speed, but that's not really but it reached that speed. So we want to use these easing formulas for our animations because it makes things look a lot better. But oh my goodness, all this stuff, MVC, easing, keyframes and transitions, how do we manage all this? How do we make this sane and workable? I built a tool called Rekapi. Rekapi gives you keyframes for JavaScript. Keyframes are something that I think are really cool. Flash used this, and although the Flash runtime isn't the best, the approach that it took to creating animation is great. And there's really nothing like this for JavaScript. So I built my own tool for this. The two primary use cases that I envision for Rekapi are building animations programmatically, like you would with jQuery or just native animation code, and creating timeline-based animation apps. Now it's time for a little bit of history. I want to tell you about the story of Rekapi because I think it's kind of cool from a library author point of view. Way back long ago, I wanted to create a timeline-based animation app. I wanted to make something like Flash, but for the browser, but not Flash. I want to use HTML5. And I realized the first thing that I need is a keyframe layer. I need some sort of keyframe API so that I can programmatically create these things and allow the user, so I can get the user access to this powerful API graphically. So I got started on a project called Kapi. It's spelled K-A-P-I, which stands for Keyframe API. I spent a few months on Kapi. It was my first library, so I had a lot of fun with it, but I made some mistakes. I made some architectural mistakes that made it not scalable and unmaintainable, but it was still a lot of fun. So I finished Kapi. It basically worked. And one day I was working on a bug, and I'm thinking, man, I'm not having fun with this right now. I need to take a break from Kapi and work on something else. So I put Kapi on the side, and I started to work on a similar project called Shifty. Shifty was a similar idea in that it's an animation tool, but it didn't take the keyframe approach. It took the asynchronous tweening approach. Again, kind of like the jQuery approach of just saying start and go, and then stop. So I spent some time with that, finished it, put it on GitHub, and people actually seemed to respond to it. It was my first open source project that people actually used for real things. It wasn't just a thought experiment. So I figured this is pretty cool. How can I take Shifty, which is built in a much better way, how can I build this back into Kapi? So I looked at Kapi, and I looked at the code and realized this isn't going to happen. This is too complex, it's not worth the effort. So I threw it away. I took Kapi and I just put it on the side, never looked at it again, and I started all over again.
So R was silent.
I'm sorry?
The R was silent.
The R was silent?
Yes.
Yes.
In Kapi, the R was silent.
Right, so I built
K.
Rekapi, which stands for rewritten Kapi.
I was thinking KR.
No, it wasn't quite. I think it's better than crappy.
Yeah.
It was my first attempt.
Yeah.
But yes, that leads us into Rekapi, which is rewritten Kapi. Well, I should put them in the README. So, what comprises Rekapi? It's got two dependencies, Shifty, which I mentioned, and it uses underscore. Underscore is a really powerful utility library by Jeremy Ashkenaz. If you've been using Backbone, then you've been using underscore the whole time, because underscore is actually a dependency of Backbone as well. So what is the 10,000-foot view of the Rekapi API? It comes down to 4 steps. First, you define some actors. Then you initialize your animation. Define some keyframes for the actors, and then you just play it. So let's take this bit by bit. Let's look at the model. So the model is represented by the global Kapi object. The Kapi object just calculates the current state based on time. This is the key. So this Kapi object calculates the state based on time and it passes it into the Kapi.actor. Now you can have as many of these as you want, and when you start having a lot of these in one animation, you can make for some really cool complex compositions. All Kapi.actor does is it wraps either a canvas drawing function for the HTML5 canvas, or it wraps a DOM element. And then we just have some miscellaneous controller type functions, play from, so you can just control when it starts, pause and stop. There's a few more, but these are the biggest ones. So enough talk. This is a talk about animation. You probably want to see some animations, right?
Yes.
Alrighty, so let's see what this thing can do. There we go. So it's really huge for this screen, but this is the Rekapi homepage. This is actually running locally, but you can actually go to it by going to rekapi.com. And there's a few demos that I want to show you. The first one is the most basic. It's my little tweening Octocat. I love the Octocat. So this is just a DOM animation. That's just a regular image tag, and it just goes on a loop. The next animation I want to show you is my Confetti Demo. I really like this one. So this is just a canvas animation, and what this does is it generates a bunch of keyframes for all these little circles. It just makes it makes some random destination points and gives them some random speeds, but it syncs them all up at key points. You can see they all start and stop at the same time. And the cool thing about this is that it actually generates each cycle on the fly. So you're never seeing the same thing twice. Even if you just sit here and stare at it, it's like a snowflake. You'll never see it again twice. The other thing I want to show you is something that a Flash developer named Jonathan Taylor is working on. It's not quite done, but I think it looks really cool. He likes Star Wars. So this is actually another canvas animation. It's meant to resemble the OS 10 word of the day screensaver, if you're familiar with that. And it just moves some words around, and it then just brings in a little description of Endor, I believe it is. Yep, there it is. And then it starts over again. But this is just running on a loop, so it's got the exact same keyframes for every iteration through the animation. So now we've seen some cool things that Rekapi can do. Let's see how to use it. So as I said, the first step is to define some actors. We're just going to use one actor for this demonstration. So we create a new Kapi.actor, and this is mainly boilerplate code. All this code in the middle is just a drawing function to render a circle to a canvas. If you're familiar with the HTML5 Canvas API, it's a little bit hairy. But we can just see that we're passing it the context to the canvas. Again, this is standard HTML5 API. And then we give it the state. This is the state that's computed by the model based on whatever frame we're currently in. Takes this state and then just renders it all. Again, you don't have to worry about this code in the middle. The important part is the new Kapi and then a draw function with this standard interface. So now we've got our actor. We need to initialize the animation. So we grab our canvas from the DOM, then we pass that into the Kapi constructor, which is our model. Save a reference to that. And then we take our Kapi and we add our actor that we just defined with Kapi.addActor actor. Here's the fun part. So now that we've got our actor, we put it in the animation, we want to define some keyframes for it. For this, we're just going to have a one-step animation. We're going to start with keyframe 0. Keyframe 0 means it starts at millisecond 0 for the beginning of the animation. We're going to give it an X and Y of 50 and a color of red. Then we're going to place a keyframe at keyframe 2000, 2 seconds in, and we're going to give it an X of 200 and a Y of 100 and give it a color of green. The last part here is where we define our easing formula. It's ease out expo. It's worth noting that Rekapi inherits its easing formulas from Shifty, and Shifty gets its easing formulas from the standard set of Robert Penner formulas. Robert Penner he's kind of made like the industry standard easing formulas, and I at least wanted to mention his name because he's pretty important in the world of animation.
jQuery baked his in, yeah.
Yeah, I think jQuery UI uses it.
Right.
Like I think he made his formulas for Flash initially in AS3, and then they just kind of got like rewritten for JavaScript.
What's his name again?
Robert Penner. Like Penner, like writing the pen. He's got a Twitter. You should follow him. He has some interesting tweets. So we've got everything set up, and now we just play it. So let's see what we just wrote. This is the animation that we just wrote. It's just a one-step tween. Twins from the bottom left, top left to the bottom right, changes the color. Simple, right? It works. Not that exciting, but we have a ball animating. So that's pretty cool. But I want to revisit something. Let's look at easing again. Again, I was just mentioning Robert Penner, and there's something cool about easing formulas. When you animate the x and the y axis on the same easing formula, whatever you're moving moves in a straight line. It looks better than if it's moving linearly, but it's still moving in a straight line. And I found out through a lot of tinkering that if you mismatch the easing formulas for the x and the y, you can get all sorts of really cool curves. I'm sorry?
The Seishu.
One more time?
The Seishu.
Seishu?
The Seishu.
Seishu. I'm not.
Seashells.
Seashells.
No, the Seishu. The Seishu patterns.
Oh, I've never heard of that term.
On an oscilloscope, if you remember what those are, basically if you mismatch the x and y, you get a pattern, several different sign this way and a sign this way, and it fills it up. Like the beginning of the outer limits has that in there. You can see the different patterns. If you have one for one, then you get one side way and one side weird. You get a circle. If you have two, then you get this little figure eight type of thing. Those are called the Seishu patterns.
Oh, I actually didn't know that. I'll be completely honest, I'm really bad at math.
Everybody over 50 knows about this.
I'm 25, so it's a little bit before my time.
You missed it.
But it sounds accurate enough. I'll have to look it up.
It's a French spelling, by the way.
Okay.
And so good luck at that.
Most of the big math concepts are French, named for French things, like Bezier curve. Anyways, so if you mismatch the easing formulas on your tween, then you get all sorts of curves. Fortunately, Rekapi supports this type of logic. So here's a similar animation before. It's got the same two keyframes at 50, 50, 200, 100. But down here, we're specifying that we want to animate X on ease in quart and Y on ease out cubic. So let's see what this looks like. So here's the same thing, same two keyframes, but we can see that we've got this nice curve here. So it goes down and then goes off to the side. There's a lot you can do with this. But unfortunately, if you want to just play with easing formulas and change keyframes, this isn't very fun. Kind of like the whole Brett Victor talk, where it's like, you gotta change the code and refresh. I don't want to do that. I hate doing that. So I built a little tool. It's part of Rekapi. And it's just part of the repo. If you go to rekapi.com, again, you'll have it. Or you can download it locally. But if we click this, we have this nice little app. And we just take these two crosshairs and move them around. So we can kind of like scaffold our tween. And then we can change whatever easing formulas that we want. So we change the X to be ease in out cubic, and the Y is still linear. And we have this nice curve going, this nice little curve going from the bottom left to the top right. Looks really cool. And we can make it even more complex by changing the easing formula on the Y. Let's give it bounce, for example. And we have this dual curve thing going here. It looks really cool. And you can just take it and move it on the fly. Change it however you need. A fun one is elastic. Where is that? There it is. That's a weird one. So it doesn't even actually start at the initial setting. It starts with the at the destination Y of the target point. It's pretty cool. And also this little app lets you specify custom easing formulas. So if we did this, oh I'm sorry, this one, we made this 2. That's not very noticeable. Oh, I hit the wrong formula. We take this, we get 6. Not very noticeable. Make it 16. There we go. So this is a great way of scaffolding an animation and seeing what it's going to look like.
Can you do multiple layer things there without having how much overhead? Like if you want to layer several different things on an element.
I mean, have more than one ball animating?
Not just one wall, but like layered.
Like multiple steps?
Yeah, multiple layered at the same time. Without how much overhead did you look at that?
I don't quite follow what you mean by that. I can't really visualize what you mean by multi-layered steps on
multiple walls.
Not just walls, but like say I have an element, then I do a hover card, and on top of that, I'm letting people dynamically make changes in that, like Table does with the elements on hover.
Oh, you mean like an onion skinning thing?
Yeah.
Oh, no, this doesn't do that. I actually, in an earlier iteration, I didn't have it clear the canvas, so I kind of had something like that, but
Yeah. So you can do much layers.
Let's revisit this in a little bit, though.
Yeah.
Oop. There we go. So that's the multiple easing formula approach. So the advantages to using Rekapi are that it gives you this powerful, intuitive keyframe interface that the Flash guys have been enjoying for years. And we also get this really nice curve control that you just saw, so you can make some really interesting animations and motions. Now, it would be fair to talk about the advantages of Rekapi if I didn't point out some of the disadvantages. Namely, views are left undefined. As I was saying, the model and the controller are consistent from animation to animation, but the view differs. So Rekapi does not attempt to solve this problem because it's hard to say what you're going to need. So you can conceivably you could port in some other library that gives you a drawing layer, that gives you tools for creating rectangles and circles and whatnot. But Rekapi doesn't do this, it just animates these things once you define the actors. So that's pretty cool. What else can it do? I've shown you a nice API, but again, it's there's not that much there. So I built some things on top of Rekapi to make it more useful for you. So we actually just saw this, but I've got a side project also on my GitHub. It's called Rekapi Controls. And what Rekapi Controls aims to do is to create a set of graphical UI components so you can control an animation. Let's take a look at how that looks again. I was using it a moment ago, but I just want to point it out. It's actually down here. So this is actually not built into the app. This is let's scroll up a little bit. This is a reusable component you can just download and implement for your animations. So you can take this and move it around, and then just play and pause it. So this is great because it makes debugging and testing animations much easier. Again, I don't like having to refresh the page every time. I want to take kind of like a movie file, I want to just take a scrubber and have very granular control over it. So that's Rekapi Controls. And this one's a little bit more exciting in my opinion. So I was talking before about why CSS animation is so great. And I wanted to harness that power. All I've been showing you so far with Rekapi are JavaScript-based animations. But what if we want to do something with CSS? What if we want to have like a very complex multi-step animation with CSS? Keyframes. It's very difficult. The API for CSS keyframes isn't the best, and you're kind of limited to what you've hard-coded into your style sheet. So I built in a toCSS function to Rekapi, so you can just take the current state of your Rekapi animation and export it to CSS. So let's see how this works. Another demo that's part of the Rekapi repo, CSS. Now, this first one's not that exciting. It's just another div animating from top left to the bottom right on a curve. This is a one-step animation. But here's the cool thing. This is not using JavaScript to move this thing. It's using JavaScript to generate an animation within CSS, and then it just puts it into the DOM and starts it. So let's see what the code for this looks like. Just view the source. Can you guys see this?
Yes.
Is that better? Okay, so again, it's kind of basic, Rekapi setup codes, specify some keyframes. Here's the cool thing. We take animation to CSS, store that. Just want to generate this for WebKit and Mozilla. And then we're going to create a dynamic style element. We're going to inject our new CSS code into the style element, and then append that style element into the head of the document. What that does is that the animation takes effect immediately. And we can see that if I bring up the Chrome DevTools here, and if we just open up the head, look at this last interesting, different looking style sheet, pop it open, and we have a whole lot of CSS. Now, why do we have so much CSS? Why is it so verbose? Because as I was saying, the CSS3 keyframe spec only gives us, I think it's 5 keyframes. I'm sorry, 5 different easing formulas. Rekapi gives you an infinite amount. It's got a standard set, but you can add your own. And the way we achieve this this nice curve animation with CSS3 is by just defining a whole bunch of different keyframes, just putting them all together, and it makes this curve effect. So I'll refresh this, you can see it. You really can't do this with just handwriting CSS3. You can, but you probably don't want to write all those different little steps. It's not fun. So Rekapi does that for you.
Have you lost the advantage of speed by populating it with so many iterations? I haven't done any performance testing, I'll be honest. I actually wrote this functionality in like a weekend, a few weeks back, and I had time to really stress test it as much as I'd like. So there's still some tweaking that needs to be done, but this is more of like a future goal of the project. But right now I've just got like basic functionality. It's not totally done yet, but kind of is, at this point it's a proof of concept that you can kind of use. But it'll get better. But I do have a performance demo actually I can show you. So I was talking about how CSS animations are so much faster than JavaScript animations. Let's put them head to head. So let's go to this demo here, open up the grid. So this is just a basic demo, and all it's doing is creating a whole bunch of divs. It's creating divs, putting them in the DOM, and it's making a keyframe for each div to animate from white to black. And I can show you both the JavaScript and the CSS version. So let's look at the JavaScript version first. Okay, so we got there, it worked, ended on time. But it kind of had this weird vibration-y effect, because it looks like it was going maybe 20 frames a second. Let's see what this looks like with CSS3. Much better. Now, the difference isn't totally huge on a MacBook Air, but if you're running this on an iPad, or if you're running this on any slower device like a netbook or any slower computer, the difference will be huge. Obviously, you're not animating like 1,000 divs like this, but you may have a lot going on in your screen. And using CSS3 to leverage all this complex motion is a much more performant way to do things because you can use the GPU. Someone had mentioned in the audience an application called Styling. I actually wrote that. So I can show it to you. Oops, let me press that. So this is styling. This takes the CSS approach again. And it looks pretty similar to the keyframe app that I was showing you that's built into Rekapi. But so we can take this and we can move it over here. I really like the Octocat. It's really cute. So I'll give us an easing formula. So now it's same thing, but if we click the CSS tab, we can see that it's generating all the CSS code for us. All this fun stuff.
Wow.
And we can move this around, do what we want, and it just generates the CSS code again. So we can easily create usable CSS animations without having to write a line of code. We can get this better performance.
What's the website?
The website?
Yeah, what's this website?
It doesn't live in its own domain right now, but you can access the live running demo on my GitHub. I'm going to put these slides online, and it's going to have a link to the repo, which also has a link to this.
So is this on Canvas or?
This is, no, this is just the DOM. And it's actually cool it's on the DOM because you're probably not animating an Octocat. You might be animating any number of things. So again, I wanted to make a tool that would make it easier to kind of scaffold these animations. So let's say we want to animate the Google logo or something. Go to Google.
Wouldn't it be faster on Canvas?
Probably not. Canvas is incredibly slow to render. And the fact that this thing can make really fast animations is because, for one, it's a pretty powerful computer, and I haven't been showing you too many complex animations. But overall, if you do performance testing, Canvas is almost always going to be slower than rendering something with the DOM. For most things, it's kind of varied. Let's take this image, copy the URL, go back to styling. Let's click on this guy. So this is where we hook up the image, and we just paste in the Google logo, and there it is.
Oh, wow.
And if we want, hang on, let's pause this so you can see it. Hello. And there it is. So you can easily test out whatever you want to animate by just pasting in some stuff and moving things around. And then taking the CSS.
There was a little bit of flickering with the cat before. I don't know if you were looking to see that?
It's not perfect.
It's not your fault. You're just telling the browser to do it. Do you know what causes that?
I do not.
Is it dropped frames or?
It's not a drop frame. I think it's just, I am telling it to do a lot. Like the code is telling it to do a lot, and it can't always keep up. So there's the occasional flicker. I do not have the answer for that because I don't actually know what solves it, other than the fact that I'm trying to do more than the computer can actually handle. For what it's worth, Firefox has really bad flickering problems. Do you want to see them?
Sure. How does this do on mobile devices?
The generated CSS code? It kind of looks like the div I was showing you before. That's the animated from red to blue. It's pretty similar performance. I'm still working on the performance of these. This is actually a very, very early version. You can see it says pre-alpha, so it's just like really kind of a tech preview type of thing.
How many points does CSS generate there?
For this, well, I can control it. This is just doing like one keyframe for every percentage throw. But I want to show you what this looks like on Firefox because it looks absolutely terrible. There we go. Yeah, that looks not wonderful. I won't say it's totally Firefox's fault. I mean, I'll take ownership of the fact that I could probably optimize this a bit. But in general, I've seen it with Firefox that there's a lot of flickering. Ironically, if you turn on the WebGL debugger that's built in OS 10, it goes away. But that's bizarre.
There's a recent bug in Chrome actually with the hardware accelerator for WebGL.
I don't doubt it. I mean, this stuff is pretty cutting edge, so probably like bugs that they're being introduced or they just didn't know about.
Somebody's assigned it.
Yeah, well, I should hope so. I mean, it's still really early days for this stuff, but the potential is huge.
Question?
Yeah.
You've put most of your time into developing for WebKit, and there's like a little bit of time for Gecko. Are you planning or are you hoping to get open source support for development for Trident, say, and additional support for the different rendering engines?
It should be pretty easy. At this point, the Keyframe API, as far as I know, is completely identical except for the vendor prefix. So I just the way I generate the string, I just have to add another option for it. Really, again, this is all just generating a big string, and I'm lucky because the API is consistent. I mean, it'd probably take me like 3 minutes to add support for IE because it's just like the -ms prefix. So those are my demos and apps. So to wrap up what Rekapi is, it gives us a powerful animation API. It gives us this nice playback control, both through the standard API, play, pause, and stop, and also through the graphical controls that I showed you with the little scrubber. And most importantly, you can take your animation and export it to CSS3. This is what I think is really cool. I feel that JavaScript animations are old-fashioned. I think it's the wrong way to build an animation at this point. I think we need to start transitioning to using CSS3 animations because they can use the graphics card. What we've been missing are powerful tools to easily make these. Writing our CSS keyframes and transitions isn't very fun. It's not very efficient, and it's very, very static because you're limited to what's in your style sheet. And I think that tools like Rekapi or something similar that generates a CSS for us is going to be really powerful in helping to make the web more beautiful and more fun to use.
Talking about tools, that's what Adobe Edge does, animation in CSS3 and Sanchez Animator, same thing.
Yep, and those are great tools.
But they're going to be paid, so
exactly.
It's free.
Yeah, I like free tools. Yeah.
Can you play your animation in IE 6 or 7, even though I really don't care for them? I'm just...
Not a CSS animation.
CSS3 animation.
Right, CSS is totally out. You can have a fallback approach for that uses JavaScript. So conceivably, if like you're using Modernize or something and Rekapi, you could say like if CSS is supported, then run this function to create a CSS animation. If it's not supported, run the JavaScript animation. I actually haven't tested Rekapi in older IEs, but I go on a limb and say that if there's a lot of bugs, they're not that hard to fix. But yeah, this would be like a good bridge tool for making JavaScript and CSS animations at the same time.
Question.
Yeah.
Can you talk a little bit more about the canvas itself? Because I was hoping you would say a few more things like that.
I love the canvas. It's one of the things that made me want to get into web development because so my background is I went to school because I wanted to make video games. I ended up not doing that, but I saw Canvas as this do anything box. I also like tools like processing because it's just like make some fun stuff. Here's an API, make a circle, make a square, do cool things. And the Canvas lets us do this. It's got a very powerful API for creating these things. It's really hard to use. Like you saw the code that went into creating a circle, and there's lots of libraries out there. I think ones like Easel or Fabric. There's a lot of these drawings. Like if you go to the JS Wiki or something on GitHub.
Yeah, Canvas Fabric is Kangax.
Yeah, that guy's really smart.
Yeah,
And Canvas is, I think in Chrome it got hardware accelerated recently, support hardware accelerated.
But like I said, there's a bug in that right now. I can show you the bug on some code I wrote.
Are you saying that for JavaScript, then
yeah.
Chrome allows you to go to
Hardware acceleration
Animation
for
CSS.
Canvas, yeah.
So this defeats his argument of going to CSS.
I would argue, like, performance-wise, Canvas would be faster because DOM is inherently slow. So when you add so many divs and remove them,
There's a lot of variables with that. So if you're taking like a div and you're applying a 3D transform, that can use a graphics card. That would be really fast. And I'm kind of speaking off the top of my head here, but because the canvas has to render each frame each time, that's a lot of work. It's got to figure out all the pixel data, 60 times a second or whatever it is, and then push that to the screen. In all of my testing with Rekapi for performance, by far the biggest bottleneck is rendering. Even if I'm just rendering a circle. Also, clearing the canvas is incredibly slow. That's like the slowest operation you can do on the canvas, is just clearing it out. Yeah?
If you were drawing 40 balls on a canvas screen, I think you're doing it wrong. You really ought to have 40 canvases.
Yeah.
If you re-render a ball each time, you're getting killed. So for high performance canvas, the whole trick is to never re-render things. They have many canvases, and it's almost like, what do they call those little things you have for the old style stuff?
Blitting. Blitting.
Pre-rendering or pre-rendering? Or are we talking about
sprites?
Sprites,
so
yes.
basically, you draw something, you almost have it as a sprite, and if you want to transition between two things, like something changes shades, you have two versions of it, and then you use opacity. You just change the opacity, and that happens instantaneously on the GPU.
Yep.
And then your canvas is going spectacularly fast.
Yeah.
Because when people say canvas is slow, usually there's ways to get around that.
Yeah, I'm doing it wrong. In terms of my demos, like I haven't optimized it.
Yeah.
But for what it's worth, Rekapi is not trying to render the canvas. It basically just calls a function that you give it that supplies the canvas. So
if somebody takes the approach of basically rendering each little item as a separate canvas and then playing these other tricks, my guess is the performance will be at least as good as what you're showing here.
yeah, definitely. But for what it's worth, you can't make CSS animations on the canvas. That's not to say you can't use hardware acceleration.
Well, but you can. You can apply opacities and positioning as a CSS pre-transform to each of those individual canvases, and then
to the individual canvases themselves, though. But depending on what you're rendering, like
not the object inside canvas.
Right.
Canvas is only APIs.
Exactly. That's what I was trying to say. You can move a canvas. Like if you want to change like give an actual canvas object, position absolute and change the left and the top or translate it. Yeah, then you can use CSS animations. But if you're trying to render something inside of the canvas with the Canvas API, that can't use CSS.
Yeah, but you really want to avoid that. That's
right.
Maybe one person's arm or finger in a whole game is doing it. Everything else, you're trying to reuse already rendered scenes.
Definitely. Yeah, that'd be a much faster way to do it than just rendering X many balls onto a screen.
Yeah, but the problem with that is with the multi-layer, you have to worry about hidden object. When you look at the multi-layer, then you have to worry about hidden. When subject is behind, it's got overlaid with the other one. You make sure that the other one is get overwrite and redraw, right? And the same time, my question is it the frame rate will be variable depending on the complexity of the animation?
I'm sorry, the frame rate will be what?
You can control exact number of frame rate consistent over time.
Are you asking if you can set the frame rate?
Yes.
Yeah, that's part of the Rekapi API. It's part of the constructor. You can just give it a configuration object and specify a frame rate of whatever you want.
But it's consistent, right? It's not changing.
You can change the frame rate if you want. Is it dropping frames?
During the animation, does the frame rate change?
Well, it might drop frames, if that's what you're asking. So if
I understand about the drop frame. I said that in the case that when you set the number of frames per second, that would be consistent.
Yeah.
Impressive.
Yeah, that would be consistent.
Have you tried using SVG at all as a backend for some of this?
I haven't. There's no reason why it shouldn't work. If you wanted to, like I said, the view is completely abstract, so you can, if you just draw write the code. Oops, write the code to render an SVG. It should still work because the key takeaway with Rekapi is that it's only trying to solve one problem. It's trying to solve how do we organize an animation, how do we render the state based on real time and pass that to our actors. So your actor could be anything. It could be SVG, it could be Canvas, it could be DOM. It's completely abstract.
In general, this is hearsay from what I heard. SVG is basically very much like Canvas, but it adds almost like a DOM support, all the things that get rendered. So usually they say that if you don't need this almost like DOM way of addressing elements within an SVG rendering scene, you're faster just to do the canvas straight and then do all your own figuring out of what's on the screen.
Yeah, it's my opinion that Canvas is actually the wrong way, the wrong tool for a lot of situations. Like you were saying, there's much better ways to draw all those circles to the screen. Canvas was the easiest thing to mock up a demo in. Canvas is great if you need to generate bitmap data or do some other like random odd things, but that's what it's really powerful for. If you want to create graphs or something, then SVG is a great tool for that as well. Or if you just need to move some content around, you probably want to use the DOM. It really depends on what you're trying to do. Yeah?
So I'm sure I'm not understanding correctly, but when you showed the code to generate CSS, that has hundreds of lines, you mentioned that was because there were no support for CSS transitions to write your own easing function, sorry?
Are you asking if Rekapi supports the transitions?
No, sorry. Well, when you showed the code with hundreds of lines on the CSS generated code, I believe I heard that you said that was because there are no you cannot build your own transitions.
Right.
Easing functions.
You can't build in your own easing functions.
But you can though.
Well, you've got that Bezier one.
Bezier, yeah. Bezier, and you can literally write whatever you want.
I've heard of that. I haven't really looked into it, and I think that it kind of works. It does work with the way you're describing. And if I can get the same effect with the exact curves that I want, I'll build it into Rekapi as soon as I understand the math.
So if you Google CSS cubic Bezier and pronounce it, you'll get there's like
Okay. Yeah, I'll look that up. I would really love to not have to render like 900 lines of CSS. I think it's that's what I have so far. Like I said, the CSS function at this point is kind of like a tech demo. It can and will be much better in the future.
Well, maybe I'm adding too much, but for my engineering background, a Bezier gives you certain controls over slopes and curvatures. And it's unlikely you'll ever need more than a Bezier, because when you're trying to show physics, which is what you're trying to do, where you don't just have an instantaneous change, but you ease in, the purpose is to demonstrate physics. The physics corresponds basically to the Bezier curve. And so anything that's a higher order function than that gives you continuity way beyond things like inertias, so you don't need it. So the fact that they've got Bezier supported in CSS pretty much gives you all the tools you need.
Yeah, that's great. I want to build it in, I just don't know the math for it yet.
There's an open source project where a guy's got Bezier curve generators for
the
CSS.
Caesar project, CSS Caesar? Yeah, that's pretty cool. I was looking at that and like, I'll look at that for a reference, but so far I couldn't figure out how it's doing its magic. But look, let me show that to you actually.
MatthewLine.com Caesar. Probably have it.
We want to do a little group hack here and figure it out?
Sure.
It's MatthewLein.com / yeah, there you go.
Yeah, I've seen this before. It's pretty cool. I need to figure out how he's doing this. And I don't know if it's open source, but down here we just... Yeah, so this is what you're talking about. This is the custom using formula. This is a better way than the approach that I'm taking. He's really good at math. So this would be a great thing to build in. It's open source if anybody wants to help. And then we just
that's nice.
Move that around. Yeah, I played this before. It's a pretty cool little project.
Yeah, if you've ever worked with a vector graphics editing program, it uses Bezier curves like this, node editing.
Yeah, I think that this is also an important tool for, the future of animations on the web. And if it fits in the project, which it looks like it will, then I'll fill it in.
Hey, Jim.
Yeah.
I got a question.
Sure.
Not related to the topic, but just curious. YouTube is like, they released the HTML5 player. What's the reasoning? Just because people are going through HTML5, like why did they Splash does a pretty good job? Like what did they do with HTML5?
Are we moving to HTML5?
Because that group supports that heavily, James Carson. They're not going to pay it. He can't speak on it, but they're not going to pay Adobe. Looks like they're not going to pay Oracle.
I can't.
You can't say that. But I say I invest on a platform.
This is something I'm not sure what I can and can't.
You can't say that. You don't want to say that, but I'll say it. I'll say it. Like Kevin Lynch, rest of WIC go help.
Hey, that answer works for me.
Yeah.
Any non-YouTube related questions? Cool, thank you.
All right, everybody, thanks for coming out. That's a wrap. Thank you. Go make some sweet animations.